Lesson 4. Pressure-volume relationships in diving. Introduction. You feel the change. Some of you have experienced it when diving to the bottom of a pool or sea, or even when flying in an airplane or driving over a hill, feeling pressure in your ears. This situation is one of the most prominent examples of pressure change in the body. Pressure, depending on its relationship with volume, exhibits certain effects on expandable and non-expandable airspace within the diver's body, influencing various aspects during descent and ascent. To understand this and address potential issues, divers need to have a good grasp of the pressure-volume relationships. Therefore, underwater physics is one of the fundamental topics in diving and should be well understood by every diver. Atmospheric, hydrostatic, and absolute pressure. The underwater physical environment differs from the terrestrial environment due to changes in physical parameters such as pressure, temperature, light, and sound. Pressure is one of the characteristics that varies the most between underwater and terrestrial environments. Underwater life can be considered life in a high-pressure environment. Pressure is defined as the force acting on a unit area. It's usually expressed as force in kilograms per square centimeter and abbreviated as a bar or ATM. The Earth is surrounded by a layer of air consisting of various gases, referred to as the atmosphere. The force exerted by the atmosphere or on any point on the Earth's surface is called atmospheric pressure. The pressure exerted by the atmosphere at sea level is considered 1 bar, also known as 1 atmospheric pressure. Water is significantly denser by volume compared to air and therefore heavier. Due to this property, the pressure exerted at the base of a 10-meter column of water is equal to the pressure exerted at the base of a column of atmospheric kilometers in length. The pressure caused by water is called hydrostatic pressure. Hydrostatic pressure increased by nearly 1 atm for every 10-meter increase in depth in a salty water column. Since liquids transmit pressure equally in all directions, as depth increases, there is a continuous increase in pressure within the water. Each 10-meter block transmits the pressure acting on it to the block below it. Atmospheric pressure at the water surface affects the water environment through the transmission of pressure by liquids. As a result, pressure at 10 meters depth is influenced not only by hydrostatic pressure, but also by atmospheric pressure. This unique underwater condition is expressed using a different pressure unit. Accordingly, the sum of atmospheric pressure and hydrostatic pressure gives the absolute pressure. Pressure-volume relationships. Boyle's law. Since gases are compressible, the volume they occupy will change inversely with the ambient pressure. Boyle's gas law explains that as the pressure of a gas increases, its volume increases. Conversely, as the pressure increases, its volume decreases. Under high pressure, gas molecules come closer to each other, increasing their density and limiting the distance between molecules, thereby reducing the total volume of the gas. The formula for the pressure-volume relationship is V1 times P1 equal V2 times P2. In this formula, V1 represents the initial volume, P1 the initial pressure, V2 the final volume, and P2 the final pressure. Using this formula with a simple example, if a diver has a lung volume of 6 liters at 1 atm pressure and wants to calculate the lung volume at 2 bar pressure, the equation will be 6 times 1 equal V2 times 2, and from this equation V2 equal 2 liters will be the result. Effects of changing pressure in body airspace. Our bodies have both elastic and non-elastic physiological space, and divers also have a mask airspace in addition to this. Our physiological space include the middle ear, lungs, sinuses, and digestive system. It's accepted that the remaining part consists of fluids and incompressible solids. As the diver descends, they begin to feel a fullness in their ears. This sensation be formed due to eardrum collapsing inward with increasing pressure and can cause pain if not equalized. Divers should use one of the ear equalization techniques to relieve this fullness. The ear equalization movement should be started before feeling the fullness and should continue as the descent continues, meaning along the pressure increase and should be repeated frequently. Regardless of a diver experience and technique, they will inevitably experience such a ear squeezes in their daily life. Some physiological discomfort separate from experience can prevent equalization. The most common of these are illnesses like colds and flu that can cause upper respiratory tract blockages. During such illnesses, ear equalization may not be possible regardless of the technique used, leading to ear tissue squeeze. The air circulation in the sinus air space in the skull happens automatically as long as the upper respiratory tract is healthy. Therefore, there is no need to equalize the sinuses during the dive. However, problems can arise with the equalization of these tissues due to illnesses in the upper respiratory tract, like the sinus tissue squeeze.